then Professor Musa, Dean of Faculty of Natural and Applied Sciences. Let me introduce you to our speaker, Dr. Ago Collins Ago. He's joining us all the way from Ukraine. Dr. Ago, this is our Dean, Professor Musa, the Dean of the Faculty of Natural and Applied Sciences.
Yeah, Professor Musa, my pleasure, sir, and thank you for having me here. Thank you so much. It's my pleasure once more.
Thank you so much, Dr. Colin, Professor Colin, for your time indeed. And then we were expecting you as physical, but lately Prof. Abu told us that there are some constraints.
Yes.
So you might happen to be in Ukraine. So thank you so much for accepting, and then you're going to give the speech. We thank you a lot.
Okay, thank you very much. Thank you. Thank you, I appreciate it.
Okay, I guess we can kick things off as people join.
Okay, thank you very much for having me. I think I'll once more introduce myself. I'm Dr. Ago Collins Ago. I'm the Director of Corporate Planning and Strategy Department of National Information Technology Development Agency, which is the topmost or the foremost government regulator when it comes to information technology across both public and the private sector. Besides, they also carry out advisory services and also carry out developmental activities with respect to ICT. It is under the Federal Ministry of Communications and Digital Economy. That's our supervising ministry. So that's in a nutshell about NIDA, and that actually, to a great extent, justifies while I'm also making some of these, justifies what I'll be speaking on, the Internet of Things. I'll go straight to I will delve into the presentation I was speaking, because I understand I have just 45 minutes. Well, the Internet of Things I must mention is, before I proceed, it's very important for us to understand that Internet of Things is one of the pillars of the fourth industrial revolution, so that shows the important roles it plays when it comes to technology as a whole. So it is an area that is an enabler, absolutely, and an area that has so much potentials, especially if you consider the market value, the number of devices that will be connected maybe in the next 5 years even. Now, my presentation will be in 2 seconds. I'll just as I mentioned, just a few slides, which I will talk about now. So, okay, fine. What is Internet of Things? How did it even come about, okay? There was a word that was coined by a Procter & Gamble employee when he was actually making a presentation to the top management of the company, introducing the RFID technology for them to be, to adopt it in selling and distribution of their products. So that was when Daniel was first coined Internet of Things by Kevin Ashton. However, the other versions of it, most of you must have heard of IoE, what they call the Internet of Everything, which is actually coined by Cisco. To me, I don't see much of a difference, but if you go to the argument of Cisco, they are adding what they call people and process into it. But I feel strongly that when you use the word things already, and especially understanding the ecosystem, because Internet of Things is a whole ecosystem, understand the ecosystem of Internet of Things, to me, is basically the same thing, but used in different way, maybe due to marketing, strategy, or, trying to own certain keywords, as it is with some of these big tech companies. So now, there are a lot of definitions of Internet of Things out there. So many of them, Wikipedia has its definition and so on and so on. But as a hardware architect, when it comes to Internet of Things, I'm actually a hardware architect. I develop hardware platforms that drives the technology. So I will try to use my own understanding of Internet of Things and try to define it, okay? First of all, it's a network of interconnected physical devices and objects. Now, when I say physical devices, it could be animate or inanimate. That's why I'm trying to use the word object. So as a human being as well, you're already a part of the ecosystem. A typical example is, let me just digress a bit. Not quite long, I went to pick up a parcel from my post office. Then I was trying to check the address of the post office. I was shocked. When I went to Google, it showed me all the places I've been within the last 1 week. So basically my telephone is acting as a sensor, relaying all my activities, to a Google platform, for me to see where and where I've gone, and I could give other people access. So that's a typical example of also Internet of Things, okay? That is the physical world, an interface between the physical world and then the cyber world. It has a great, some people use the word cyber-physical systems also to represent the Internet of Things. So Internet of Things also collects data, transmits data, processes data over networks. So network could be wireless or wired network. It doesn't really matter. Now it's made up of two parts. One is the internet, which I mentioned already, is the backbone of the whole connectivities we have, which has a very, very interesting history. It has actually evolved from being, network of computers to network of networks, and then to what they call the wide world, the World Wide Web, that's WWW. So it has quite evolved as a matter of fact. Then the things, as I mentioned, is the physical object. So it brings basically the power of internet, data processing, data storage, data transmission, analytics, and so on and so forth, to reward and helps us to make very, very important decision. Now, Internet of Things is also one of the technologies that is actually driving what they call the data science. As the Internet of Things, as what we call a data generator. Because for you to even to do your back-end analytics, even applying AI, you must have some data set. So the Internet of Things acts really as a data generator through sensors, through various sensors, maybe through various front-end, devices as well. Some of them can even be single-board computers. Some of them can be a kind of, I'm struggling to use the word middleware, not to confuse things anyway. So all this, transmit, data through the Internet of Things. Now, very, very interestingly, how does all this happen? So this is where I'm trying to break it down for the layman to understand, okay? For my definition, I mentioned the word network, I mentioned things, I mentioned people, data processes, and so on and so forth. So this is a general overview of the technology when we talk about Internet of Things, because before we can start talking about the impact or implication for developing an economy, we want to understand what is it all about to start with. So as I talk of areas of applications, then my audience will be in a better position to understand. Then those of students that are conducting their research or are about to come up with some research topics, or maybe your MSc dissertation or projects, that will give you a clearer idea of some of the areas you should be looking at, because I believe strongly for the university community, every research should be must be product oriented. Research must yield something tangible that can be commercialized. Very, very important. So we have moved from the era where research are put on the shelves of the universities or other places and never applied. So this lecture will actually help us, or this section will actually help us, some of the students, understand areas they could be looking up if they want to apply some of this emerging technology. So I'll go back to what I'm talking about. So talking about network. Your network now can be your cellular network. That is what we call the GSM. Most of us are aware of. The generic name is actually what they call the terrestrial network. All the networks that are within the Earth is called a terrestrial network. Then again is what they call the satellite network. That's if you're transmitting from the satellite. Some of you have your VSAT, so that's a satellite network. Some of you may have your point-to-point or what have you. All these are terrestrial network. So the network could be cellular network, it could be point-to-point, and of late, very, very importantly, we have what they call a WP-LAN, that is LP1, that is low power wide area network. We have some big players like Sigfox, I think it's a French company that actually developing some low power transmitters that will help to backhaul data, to the back ends or the broker or the cloud application for further processors. So all this make up the network, including your gateway and so on and so forth. So the things, as I mentioned, could be animate or animate. I mean, if you say that God created everything, we understand that it involves both human beings and non-human beings and what have you. So it could be your, things could be your device, and then people, we know it's people as well. I mentioned already, you carry your phone. Your phone is a powerful sensor that extracts so much data from you and pushes a lot of data you're actually releasing. As a matter of fact, I don't know if how many of you don't even know that your Google Assistant spies on you 24 hours. As you're speaking, it's being recorded. We had a situation with my wife. We were discussing a couple of things. Just mentioned some word. The next day, she went to check a couple of things on her phone, and all those things are already showing, some of the discussions we had. So, this part of the AI, they translate your speech, interpret your speech, and try to know what you're talking about. So it's actually, a kind of a barrage of data exchange going out there. The next is data. So data is actual, I mean, let me say, is the payload, of IoT, basically data, because data is information you have. And then this information is transmitted. That is where the processing comes in, to a backend now to take some decisions. Those decisions can help you maybe, automate your activities. It can help you answer your processes if it's a business processes. For example, you want to apply it to logistics, you want to apply it to maybe smart farming, you want to apply it to smart healthcare. A typical example, I will digress a bit, is right now, thank God I took my first dose of AZT vaccine already, and I'm due for my second dose. So one of the worries I've been having is that we understand that some of these vaccines need some very strict, how do I put it now, storage conditions. So my question is that how do you monitor each of these vaccines being carried all over Nigeria? How do you know that the temperature is being observed? How do you know the storage conditions where they've kept them before they distribute it to the last mile? How do you know which one shouldn't be distributed due to the fact that the temperature has changed or what have you? That is when some of things comes in. You can actually embed what we call, very digital thermometers on this very vaccine, maybe in a cooler or what have you. And transmission of those temperatures can be coming to the medical personnel at a back end like a dashboard. So they can monitor 1,001 vaccines. They're using AI and other analytical tools. They could actually create some alarm systems where if it is going below certain threshold, it will alert you. It's going above, it's alert. So this is a very quick application of this IoT in healthcare system. I'll still talk about that. Now, as I mentioned, the data and process, the data collected plus the processing that happens at the back end gives you a visualization where you can make a certain decision. Now, what about the technology? So I've explained some of the processes involved in harnessing the power of IoT. So the next question is, what is involved in IoT as a whole? So if I open up the IoT as a case, what do I see inside? So that's what takes us to our next slide. The 4Cs, I call it the 4C technology. There are 4Cs that make up the IoT. And as I mentioned already, is a pillar, a very, very strong pillar of the fourth industrial revolution. One of the 4Cs is your control. The second C is your connectivity. Your third C is your computation, then your cloud. Then if you go back to my definition, you will see them reflected. Now, let me apply some of these 4Cs to the current situation. Let me use the word ICT, information communication technology, as a technology on its own. How are these reflected in the ICT? Well, we all know about networking. Network is a vital tool when it comes to information communication technology. So much so that some of us go through CCNA certification that is organized by Cisco Systems. Then we'll talk about cloud. Cloud is very important. That is where the database comes in. Some of us are learning things like cloud technologies like Azure, Microsoft Azure, and so on and so forth. That's where the database comes in. Most of us have gone through the classes of MySQL, SQL, Oracle, and so on and so forth. Then the next one is computation. Your computation is where your software and firmware development comes in. Some of us program in Python. Some of us program in C and CC. Some of us program in assembly. I started programming in assembly. I actually started programming. I started my embedded system journey with a PIC 16F84 made by Microchip. So my first programming experience was actually in the assembly language. And then, of course, I program also some of the machine code through my mechanical engineering classes. So we are trying to program some CNC machines and so on and so forth. Now, the next one is control. Control is where your embedded system comes, because as you plug in sensors to sense the environment, to sense certain parameters or what have you, there must be an intelligent system that should be able to extract this very information using various protocols. It could be your I2C protocol. I'm going a bit technical now. For some of us that are techies, it could be your I2C protocol. For your I2C devices, it could be your SPI protocol. It could be what they call the OW protocol. That's one wire. It could also be things like your serial protocol, maybe your UART or RS-232 or RS-485, and so on and so forth. Now, if you collapse all this together, it falls into the IoT. So you can see how powerful this technology is. It encompasses all facets of information communication technology. What it translates to researchers, to university community is that when you build capacity, you build skills in this IoT. That means automatically, man, you have a lot of spin-off benefits, that actually positions you, for a higher edge when it comes to competition, especially when it comes to things like employment when it comes to things like research. Most universities, like my university here in Ukraine, they make a lot of money themselves because they have a lot of research. They actually they make a lot of products on their own and also make so much money from patent and also from, from consulting and so on and so forth. So I believe strongly that the academic community, if they pay attention to some of this technology and build skills, some of those components of this very technology, it will actually highly position their university and the rating, of course, of their university. And inadvertently, it will help also in the employment of their students. Now, the next thing is, what is the market value? At the end of the day, everything boils down to Naira and Kobo, okay? Now, by the year 2030, from some of the research I've done online, they'll have some figures that are deviating and what have you. We'll have over 2.4 billion connected IoT devices worldwide. Sorry, 25.4 billion, 24.4 billion IoT connected devices worldwide. That is huge. And that is one of the reasons that is driving what they call the IPv6. Because at the end of the day, we want every device to have a public IP. And if you go to, if you utilize the technology of, the nomenclature of IPv4, you're still looking anywhere because we would have run out of IP addresses. So the IPv6 comes in here to play because at the end of the day, everything now should have its own public IP address so that I can talk to you directly. I don't need to go through a broker or intermediary to be able to communicate, to be able to communicate, directly. Such things could be machines. For example, I want my car to have an IP address. Yes, why not? I will Google online, log in online. I'll see everything about my car. I want to see the engine rate. I want to see how much fuel is left. I want to see so, which is actually going on now in some of these driverless cars and what have you. It's also going on. Now, again, the market value is 1.46 trillion. Trillion is 1.46. Put it 1,000 billion gives you a trillion. So the market value is 1.46 trillion. That is huge. Now, here goes the question now, okay? As developing markets, when I mean developing, I mean Africa, Asia, mainly, but I'll be focusing primarily in Africa because it's a terrain I'm quite used to. So the question goes that, with 1.46 trillion by 2027, so do we stay as spectators, and watch this technology sent to us as consumers? Or do we start doing what they call technology adaptation? That's from adoption, we go to adaptation. Do we start doing technology adaptation that will help us understand how we can inject what we call the local content or indigenous technology to make it to be sustainable? Because one of the key reasons why technologies fail in developing economies is that we get the first world technology to the third world realities. Okay, we bring to the world third world reality where they don't have power supply, maybe no connectivity, or what, it fails. But when you're able to adapt your technology, it helps it, re-engineer to suit your terrain and peculiarities. That means that we're able to, sustain that technology. That means that the value for money is reflected and so on and so forth. So that is why it's very important for us to pay attention here, where we need to build skills. Skills is actually having that knowledge on how to do things with your hands. Things has to work with you, no longer theoretical. You're coming up with your product. So that is where skills come in here. And that is what is playing a major role worldwide. So the world is driven now by talent and creativity. So it's no longer enough just for me to have my degree. No. So the question is, having my BSc, MSc, PhD, what can I do with it? What problem have I solved for my kind? What problem have I solved in my village? What problem have I solved for Nigeria, Africa, Asia, and so on and so forth? So that's another area I have to pay attention. Now, let's quickly look at the trends of IoT in the year 2021. Security is the topmost agenda all over. Actually, I'm in Ukraine right now, my sabbatical, and I'm really taking cybersecurity seriously more than ever. And, going some of the dark web areas, definitely trying to know what is happening. Most of you must have heard about onion browsers, Tor browsers, and so on and so forth. I'm making investigation also, also looking at past vulnerability, exploits and, exposure, common vulnerabilities and exposure and so on and so forth. So that issue of security is very strategic. I mean, it's one of those areas we also need to build capacity because it cuts across sectors, IoT, yes. In IoT, we have what we call the OTA. OTA means over the air. What simply put is that I've deployed 1,000 devices in the field and I need to make an update. Imagine deploying 1,000 devices across Nigeria. So I need to make an update. Do I go and pick each of the devices to update them? That would be madness. That would be costly. That would take me a month of Sundays. So the OTA means over the air. That means that I will create a firmware and a hardware system that will enable me from my room or from a central command and control post to update the whole firmware running in an IoT platform. So that's where the issue of security comes in. How will that device in the field understand that I'm the one talking to it? I'm the one sending this hex file or binary file to it to update. Imagine if it's running a very, very critical application, maybe in oil and gas, or maybe even the health area, checking patient vital signs and so on and so forth. And then a kind of a corrupted firmware is sent over there, and then it turns into something else. So it's a very, very important area we have to look at. Data analytics. As I mentioned already, IoT brings up that job. So data analytics, that's where the data science comes in, which is actually high on the menu. Then software as a service. Yes, we have what we call the broker platform. And the software that we need to develop for them in Nigeria, because working for NIDA, we have what they call localization of data policy, where we try as much as we can for government data to stay onshore, not to be taken out for various reasons. So that's where some of our data centers should actually up their game, where they create what they call the broker platform. Example of broker platform are things like TeamSpeak, things like Ubidots, platforms like Adafruit even has, I think even Arduino has some of these broker platform. Broker platform is basically where a device transmits the data. Let me digress a bit since we're talking about IoT to break it, especially for the students. Now, one what is called the DHCP, that's the dynamic allocation of IP addresses. Each time you're using a mobile device, you come online, you hardly retain the same IP address. You hardly, because it's not a public one. I can say you hardly retain it. So imagine a situation where I'm staying in Nigeria, I need to talk to device B. Maybe, okay, for example, I'm in Ukraine right now. I need to talk to device B located in Nile University right now, okay? Now, each time, yes, we have already had a handshake, the device recognizes my IP address and so on and so forth, so no problems. But each time I switch on my phone, the IP address changes. So what do I do in that situation? If I transmit, the device doesn't recognize me at all. It doesn't know who I am because the IP address have changed. So that's why some smart people came up with what they call an intermediary system called the broker platform. The broker platform is like a cloud application where both of you agree. So you go into the cloud application, you create your account, and API is given to you. So that's why another important terminology is coming in now. API, what they call the REST API, and so on and so forth. So APIs are special keys given to you that enables you to write and read. That is, you can talk and listen to devices in the field. So for that very cloud application is where you embed your keys in any communication you're trying to send or receive data or what have you. So the authentication is done by the cloud application as a broker, as a middleman that lets you people talk. So it doesn't matter if your IP addresses is changing or not changing. If there were no cloud application, that means that each device must have had a static, a public IP address, which have been quite a bit of a problem at this period, because the IPv6 is still evolving at this very period. Not all devices actually support IPv6, but as time goes on, I think it becomes a possibility to talk directly bypassing some of these broker platforms. However, let me point out something. I'm not saying it's not possible to talk directly to a device. I could talk within a wide area network. Right now, if I could play a wide area network where I have a dedicated IP addresses, I could talk directly bypassing any broker, just like having your point-to-point communication. So that's it with the PowerPoint. Now, let me come down to areas of application. One of the greatest areas of application of this very Internet of Things, since we're talking about the implication for developing the economy, is the healthcare, the healthcare sector. There's a going that the wealth of a nation the health of a nation is the wealth of a nation. Let me take Nigeria for example. We have primary health care in the 774 local governments of Nigeria. Now, my question is that, does Ministry of Health have a visibility down to the nodes? In my local government, in Kano West of Enugu State, do they have a visibility to know who has come, who hasn't come? Second one is diagnostics, okay? A lady comes in there, how do you diagnose some of her, problems because we may not have some specialist expert doctors there. Some people may start telling me about telemedicine. Telemedicine is expensive. It's expensive and what have you. So that is where the M-Health comes in. M-Health, that's mobile health. And that this mobile health is driven by by IoT. As I speak with you, Kenyans are using it. South Africans are using it for the rural areas where they basically give maybe a pregnant woman or someone that is really sick, give something like a belt they tie to their body, and all the vital signals, everything is being streamed, from the mobile network now to a backend where they can be a consultant. The consultant can be sitting in a national hospital, monitoring multiple, health facilities across Nigeria. So some of your vital signs could be your temperature. You could check your, what they call your SpO2. That is oxygen concentration level in your blood. And I have to mention actually that that's one of the signs they check when it comes to this COVID-19 pandemic that we have. If you actually see, they check the concentration of they check the SpO2 level in your blood. If it goes really down, that means there's danger. So you can actually have a situation where you may not need to monitor 1,001 patients. Imagine a situation where we're lacking doctors and you're bringing 2,000 patients. How do you monitor them? So that's where the IoT comes in. Each of these patients can be given what they call the wearables, where they can attach to their body, and all this information is being streamed to a central computer that can raise an alert, send the SMS to doctors, and so on and so forth. So it is a technology that is good for Africa because it helps us now bridge the gap of infrastructural deficits, where we don't have what is deployed. That's where IoT comes in. It helps us bridge that gap. Because I can have one doctor in Abuja take off 1,001 patients across Nigeria, so long as there's a cellular connectivity or there's a network for me to backhaul the data. And that is where the technology mix comes in, what they call the how do I put it now, the transmission mix, where you can have your cellular transmission, where you can also have your satellite. So they can actually mix it. I'll give a typical example. There are some areas in my local government with GSM blackout. So somebody may be asking me, okay, fine, where there's no connectivity, how do you want to relay the data? Yes, please.
Excuse me, Dr. Ago. I'm sorry for the interruption. Please, I've sent you a link I want us to switch to. I'm very sorry for the disruption.
Okay.
We're running out of time on this. I've sent you a new link, a university link to switch to.
Okay,